G'day viewers, Alan here. Welcome to my workshop and to episode 6 of my Webster journey. Christmas edition perhaps. Anyway, so in this episode I finish off the valves and the gears which drive the rocker arm, which raises and lowers the exhaust, which opens the exhaust valve. The gears I've made are not as specified. I went for a metric gear set using an M0.8 gear cutter, and that caused issues. I had to move the hole that one of the shafts fits in. Anyway, let's dive in and you can see how it all worked out. So I turned up the second valve, and as you can see they're pretty small. The valve faces are only a ½ millimetre thick. That's a bit hard to measure because the back of the valve face is at 45 degrees, so you can't sort of get a very definitive reading on it. Anyway, I managed to get them pretty close to ½ millimetre, so I was happy with that. Okay, please excuse the sound of rain in the background, but I'm in the process of drilling the hole for the valve retaining pins. So you might be able to just see there's the end of a 1 millimetre diameter pin. This is bloody microsurgery, but anyway. So to make this work, you have to drill a 1 millimetre hole through the valve stem, on centre hopefully, and correct distance in. So the way I chose to do it was with I don't have any V-blocks that are suitable for this, so I got hold of a scrap of aluminium and drilled a valve stem size hole through that way, and then was able to measure from the outside face of the valve through and then put a hole in. Yeah, but you can tell from the chewed up jig here or fixture that it didn't all go smoothly, and I broke the drill. I was trying to go with the number 62 drill because I wanted the hole to be a bit tight on the 1 millimetre pin, but that drill broke, and I've got a couple of pictures here showing that disaster. Anyway, I was able to mill into the fixture on both sides and grab hold of the broken bit of drill and pull it out, and then put this valve back into it and finish the job using a 1 millimetre drill. So anyway, it'll perhaps make a bit more sense when I mount it in the vise and get set to drill the hole. Okay, so I imagine you can see I've got an indexing a marker here, and I'll be able to use this one on this end, so that will position these two blocks and sandwich a piece between them. So that means I can reuse the setup I had for the first one. So the valve's quite a good fit into the fixture. It's just going in like that, and so that can sit in there. Push that over, come around the other side. I'll just tip this down. So that's quite firmly holding that already. So now I can put a gentle pressure on the end of the valve face, holding the valve into the block. I'm not putting much force on it with the drill, so that should work out just fine. But that way I know exactly where it is. So the drawing calls for the hole in the valve stem to be 22.62 from the front face of the valve. So that's what this jig allows me to achieve. So I'll use the wiggler thing and got it all set up. So that should line up on the hole from the first debacle, which, well, I call it that. It didn't go as planned, but I did finish up with the hole in the valve stem in the right place, so it wasn't a total disaster. Alright, but what I learnt from that is not to use the hand wheel to feed the drill down. You've got to have very delicate touch. Alright, also I've got the drill set to run at 3000 RPM as well, because it's such a small drill. Okay, so we can pull the valve out. A bit hard to get that in focus, but there's the 1mm hole without a broken drill, so I'm going to call that a win. Okay, so I'm doing a final assembly on these valve guides, and the instructions say to Loctite them in. I actually made them with a fairly close fit. They are a light press fit into the blocks, but belts and braces never hurt. So I'm going to hit them with some Loctite. So I'm going to hit them with some Loctite 948 retaining compound, and hopefully I won't get myself in extreme mess, although I probably will. Just going to squeeze out everywhere, of course. That's just what it does. Let's see if we can get the two pieces together. Alright. Press it the rest of the way. Trying not to drop it. Let's turn that around, be easy to get hold of. Come on, get in there. Right, let's clean the mess off. And that IPA seems to work as good as anything to make it easier to clean this crap off. Yeah, that's gone in nicely. I'll wipe it off the back. Give another squirt for fun. It's just regular isopropyl IPA. It's a mouthful to say the whole thing. Let's give another wipe off. There we have it. So the only thing left to do now with these is drill these ports out, which you can't do until after you've done the final assembly. So over to the drilling machine to do that. Okay, so I've got it in the vise ready for drilling, and I've lined it up using the wobbler, but I want to check to make sure I'm as precise as I can. So I've got a 0.218 dowel pin in there. Okay, so we'll check the alignment with that. Yeah, that's pretty good. I'll go with that. I have to drill this 7/32 hole in it. I think it's 7/32, so I'll just check that. No, in fact it's a 3/16. That's just what I checked. Right, now this has to go down 1/2 inch from that face, so I'm going to have to move over a bit so I can set that. This is where DROs are fantastic. So, all set to go now, down 12.7, 1/2 inch, whichever you prefer. Off we go. By the feel of it, I've just started touching the brass, the feel of the drill's changed. Well, hopefully that's one done. Set my to locate the next one. Alright, well that certainly created a port through into the valve guide chamber, and in the process raised a wicked burr in there which I'll have to deal with. Anyway, on to the next one. And there's the other one done. Just got to clean that one out now. So that's that one done. I think it probably cleaned up slightly better than the other one, but either way I'm sure they're both good enough. Okay, well that finishes out the machining for the top end of the valve train. As you can see, working the rocker arm opens and closes the exhaust valve on the bottom. The inlet valve, I think they call it atmospheric, is opened when the piston draws down and draws vacuum. Here it will pull the valve open. Now the valve retainer, the drawing just shows it as a flat disc with a pin through a hole in the valve stem. But I couldn't understand, maybe I'm stupid and missed something, but I couldn't understand what was going to hold that pin in place, stop it falling out. So as you will see in this detailed picture, I machined a rebate in the top face of the retainer, so that pin is now captive. The spring pressure holds it basically in the dish, so it can't ever come out. So to do that little rebate, I had to make up a holder for a 4mm diameter boring bar. It looked a bit lost on my big lathe, but it did get that little rebate done, because it's only 0.5 millimetre deep and about 4mm across. Anyway, so moving on from that, I'm going to switch over to doing the timing gears. I'd already made the cam, you'll remember perhaps from a previous thing. Already made the cam lobe. Oops. Oh, stay there somewhere. Whatever. No, it's out of the picture, isn't it? Now, it's to be a press fit on one of 2 timing gears. Now, the drawings call out for the timing gears to be DP32, a 48 tooth and a 24 tooth pair, i.e. 2:1 ratio. And I didn't think about it when I started making the frame, and just drilled the holes as per the instructions. But when it came time to source the DP32 gear cutter, I got a shock. Not easily obtained in Australia, and importable from the UK or possibly the US at considerable expense. And I didn't want to do that for something I might never use again. So I chose instead to buy a set of M0.8 cutters for metric gears, and I got a full set for less than the cost of buying the 2 that would have been needed for the specified gears. So I'll pull up a picture that shows the consequences of that. The 2 gears I have to make are essentially pretty close to the same diameter as the specified pair, and the centre distance is quite close, but quite close doesn't really cut it. So I'm going to have to move the hole which I previously drilled in the side frame to a correct position for the spacing required for these 2 metric gears. Anyway, that's the next thing to get onto. So this is the blank for the 50 tooth gear. I've got the OD set. It hasn't got a very good surface finish. This is some mystery metal, I don't know, some scrap lying around, and it's not machining very nicely. It doesn't matter to me though. So this diamond, this smaller OD here, is for the exhaust cam, and that will be a press fit on there. That's that. And now I have to bore this out to be 6mm to suit the camshaft that I've made. So what I'm looking for is for this gear blank to be a nice running fit on that. And I've taken a couple of runs, and I'm thinking this might be the final run. Alright, I think we got it. See the trap tears pushing it back out. That's as good a fit as I need to have. Next stage is to part this off, or hack it off and then face it. I'm not sure what I'm going to do yet. So I decided I would have a go at parting it off. I mean, I don't know what this metal is, but perhaps it will part off. We'll find out. Actually, surprisingly, cutting quite nicely. Seemed to up the speed 1 notch. I'm really surprised how easily that's parting, how well it's cutting. Right, well, it's time to get some sort of a catching pole in there. Actually, that parted that off really nicely. I was a bit surprised. There you go. Mystery metals. Okay, so making up an arbor for the gear cutter. It's a 25 diameter here, so pretty stout, and this threaded piece here is going to be threaded M16 1.5, and with a lead screw of 6mm pitch means I can open and close the half nuts anywhere on, and makes it easier. Anyway, going to do a scratch pass to start with. Yeah, I think we're on the money. Clean some of the whiskers off and have a first look at that thread. Yeah, let's go a bit deeper yet. So before I started to cut the teeth, I thought it'd be a good idea to check the runabout. Sorry, the builders have moved in next door, and you'll probably hear assorted screeches and thumps and whatever in the background. I'll try to work around it, but my apologies. Anyway, so I've got my gear blank mounted on an adapted spindle in an ER40 collet in the rotary table. And I thought before I started to cut the teeth, I'd check the run out, and got a nasty surprise. I've got really quite an unpleasant amount of run out here. My first thought was that, what's that, about 0.13. My first thought was it would all have been in my disc and arbor and so on. But as you'll see, when I started to check into what was going on, there's more to it than that. So, as you can see, I've run into a bit of an issue with my Vertex rotary table. This is the first time I think I've ever actually done a run-out test on the Morse 3 Morse taper centre socket, but you can see that it's got a run-out of 0.05. Which is not what I wanted to see. If I reset the dial gauge to track the outside diameter of the thing, we'll get a different result. So starting from 0, the maximum run out looks like it's about 0.02. Maybe 0.03. Either way, much less than the run out in that Morse taper socket. So I'm curious as to how this could be. According to the manual that came with the machine, the socket is supposed to be a precision thing. It does describe it as being a Morse taper sleeve, so I don't know whether that means it's removable and could be replaced with something else. But I'd be really interested to hear from anybody who can offer any advice on what I can do about this problem. Right, so after an enormous amount of messing around, I think I've got a way forwards. I've got this dialed in now so that the run out on this is about 0.01. I'll show you that in a tick. So I had to dial in the turntable, then dial in the blooming chuck, and then this is not a particularly good chuck, so I couldn't get an acceptable result with this thing mounted directly in the chuck, so I put the hexagon collet block in there, and that's a 0.002 of an inch shim, and finally got to a point where I could get an acceptable result. So it turned out that the concentricity of my machining was fine, and the problem I was having was in the rotary table, and that wasn't what I was expecting to find. Anyway, I have to turn this lot over now so I can cut the teeth on my wheel. So I've stood the rotary table up in the vertical orientation and added the dividing wheel singular, and I've set it up for doing 50 teeth. I'm going to use the 30 hole ring, and so I'll have to use 1 full revolution plus 24 holes for each step. This is my arbor you saw me making on the lathe, or start to make. I don't know whether you'll be able to pick it up. So I've zoomed in so that you can see it. The cutting wheel, the cutter, is quite a tight fit on the land I've machined into the end of the arbor. But to make sure it can't turn, because that's a right-hand thread, I should have done a left-hand thread, but I didn't think about it in time. But anyway, to make sure that can't turn, I've let in a 4mm key, which will engage on the notch in the cutter. So that take care of that. And it's 25 diameter, so it's pretty beefy. It shouldn't muck around terribly much, hopefully. As you saw previously, I managed to get the blank running true. So just got to bring them together and get started. So off we go for the first tooth. I'll be doing a depth of cut of 1.8mm. Well, that's the first cut done. That seemed to work fine, so bodes well for the rest. Okay, with the first tooth cut, it's time to rotate the blank for the next tooth, next position for the next tooth. So do 1 full revolution and then around 24 spaces as marked by the sector finger. We're now in the correct position for the next tooth, but we'll wind this around as part of the go. So after we've done this next tooth, we're ready to repeat the process. Doesn't matter when you do this, rotate the sector fingers, you just need to be consistent so you step round correctly. So we're getting down to the short end now. There's not many teeth left to do. We'll soon find out whether or not I've got the right number of teeth. Well, looks like I've got a correct number of teeth for the size of the gear. Just got to count them now, make sure it's actually 50. Okay, so I've made the other gear, the little gear, and that turned out fine. But when I put them together and checked the meshing, I found there was actually a problem with this guy. Several of the teeth aren't correctly formed, and there was a bit of a clash. I corrected it to a degree with a file, and now they mesh all right, but there is a rough part just there actually, so I don't know whether you'll be able to pick it up, but these teeth here I took a file to get them to mesh. So I'll be remaking this gear, but for the time being, because I've got the issue with the rotary table, I'm going to press on with it the way it is. I think it will work just fine, but it's really annoying that they don't mesh as smoothly all the way around. Anyway, I don't think it's a big enough problem to stop me, so I'm going to carry on. Okay, as I've said previously, I'm not using the originally specified gears, DP32 or whatever it is they are, and I'm using metric module gears with M0.8. and you've seen me make the gears. This one's turned out alright, the 25 tooth, this one not, the 50 tooth, and I'll probably be remaking this, but it'll serve as a model at the moment. Anyway, you can see with the original centre to centre distance, because the gears are slightly larger in diameter, they won't mesh. So clearly I have to increase the centre to centre distance. That has to increase by only about 1.5 millimetres, but I can't just move it in that direction because there won't be enough clearance for the gear. So to preserve that clearance, I've got to move it that way about 5 millimetres, which will give me the increase in that centre to centre distance. So how am I going to do that? It'd be nice if we could just, as they do in the cartoons, just drag it 5 millimetres, but clearly I can't do that. So what I'm going to do is bore it out with a 16 millimetre end mill, and that will just catch this side and leave me with a 16 mil hole, and then I'll machine up on the lathe a plug for that diameter, and the centre line of the moves post will be in the centre of that plug. Well, that's the plan anyway. Let's see how that works out. Okay, so I've lined the side frame up on the crankshaft bearing hole, and I've got a pretty good alignment there, so that's fine. So now I've got used the CAD package to work out the Y offset and the X offset to get to the new centre position. So let's get a 16 mil end mill in there and get cracking. Actually, I think I'll do it with a 14 mil end mill to start with, and then do a second pass with a 16. Okay, so it's kill or cure time. Well, that was a disaster. I didn't have it done up tightly enough in the vise. Okay, take two. Repositioned, just as well I started with the undersized cutter. Right, let's see how we go. And in fact, we're through. Well, that seemed to work pretty well. I think you might be able to see just the edge of the original hole. So anyway, that was done with a 14 mil cutter, so now I'm going to do 16. It should be completely cover that hole, or remove it, whichever is the right way to say it. So that's the cutter I was using. Aprica is an Australian brand. It's a guy in Melbourne somewhere, I think. He does his own sourcing, and Aprica is his brand. Anyway, that's the cutter. A 3-lipped slot drill. And as you saw, it did a pretty fair job in that aluminium. So I've finished the hole now with a 16mm 2-flute, same brand actually, Aprica. So that's given me a nice clean hole to work with, and it has just cleaned up that original hole, so that's perfect. Okay, so it's over to the lathe now to make the bung up. Okay, so I've made my bung, bush, whatever you want to call it. Pretty simple turning operation. And I've tried to undersize the hole, both holes, both holes I suppose, by about 0.02 of an inch, because I really like it to be quite a good press fit. Well, it started in the hole, so that's a good sign. We press on. Alright, I don't want to go all the way down flat, so let's just have a look at that. You could see from the release of pressure that there was a good push happening. So it's looking good, really good actually. Unfortunately I stopped a little bit too soon. So now it's going to be difficult working out how to position the washer, because I want it to come out beyond the face here. I don't think I should rush into this, so I'll give it a bit of thought how to finish pressing it so I don't mess things up. Okay, so I found some larger washers, and I can index it against the brass bush so I know where they are. So I changed my mind and decided I would push it flush with this side, and I think that's a pretty good call. That's worked out pretty well. Certainly finished up dead flush. It's just a slight burr from the edge of the hole there. So very happy with that. And on this side I've got a bit of an intrusion which I can now machine down. There's a slight burr around there I just want to clean off, but I don't need to go any deeper. I've decided I'll just touch this a little bit with a slightly larger cutter to clean that burr off. Right, I'm not pushing my luck any further. So I do not want to go low. You can still feel that's ever so slightly high, but so what? I mean, it's always going to look like it's a let-in, so we'll call that done. Very happy with the outcome. Now, of course, now we've got to find out whether or not my holes line up, whether my hole spacing is correct after all that. Alright, well, as you can see, I've pressed the rocker cam shaft in, and that was quite a tight press too. It's not coming out. Anyway, so I'm very happy with the way that the bung and the shaft turned out, and the gear doesn't engage as nicely as I would like, but that's because there's some of the teeth on the gear I don't know how it happened, but they're not properly formed, so I'll have to be cutting that again. But anyway, I'm happy that this gear pair is going to work, and I can move on with the rest of the project. Okay, so I'm going to end this episode here. I did fit the small gear to the flywheel, and that's permanently done. I haven't fitted the exhaust cam to the larger gear because, as I've said, I'm going to be remaking that, so there's no point. But it did serve to allow me to sort out the spacing of the gears and get all that finalised. So, wins and losses, but quite a bit more progress, I think. Anyway, time to wrap up for this year, really, I suppose. I'd like to wish you and your family and friends a happy and safe Christmas, and I look forward to seeing you in the next episode in the new year. Thanks for watching this one anyway, and cheers.